Good morning, good afternoon, or good evening, depending upon where you live around the world. Well, what a journey it has been, or still is, but I can suggest that I may have fallen across a simple solution to my dilemma. Now, as part of my journey in this dome construction process, a lot of it's based on theory and gut feeling, and often we'll come up with the next best thing and find out that someone's already tried it and have been using it, or it's a little bit more complicated than I wish to pursue. Now, one of the things was I wanted to make something that in the dome structure that is easy to build in the workshop for the average person with the average workshop type of tool. And some of the ideas were quite good and still are, but they have issues. And every time I came up with a solution, I thought, oh, crikey, that's a clunky way of doing it, or it's going to bite me in some way. And then I had a couple of thoughts, of which I haven't followed up on, but at the same time I'm thinking, by crikey, those people that are building the dome successfully and enjoying their results of their construction, they're not worrying about this sort of thing. However, my criteria is slightly different, I believe. I say that to make myself feel good, but I also want to be able to scale this up in size, and I think the choice, it's almost like a hybrid type of interface between the strut and the hub. I think it will scale very well. Now, I've already mentioned that I was considering having a threaded rod inserted into the timber. That failed when I thought it would thread in, and just the sheer number of thread in with the fibres would have been fine. But I tried it, and the particular example I tried on the first go, it failed, and it proved to me, surprisingly to be fair, that it's not a good idea. But I'd already gone down the road where I said, if we put a steel dowel, solid rod, through the strut with a thread in it, we can thread a threaded rod. We can slide a threaded rod in and screw into that dowel. Now, these are just the same sort of thing. This is just the big brother or sister of the furniture type joinery connections that you probably have used yourself. So this is just a bigger version of it. So I haven't come up with anything particularly clever. But, and the major part of the loading will be this rod here, and that's why it had to be quite beefy. Lesser is this top one, but it wasn't non-existent. But I was trying to come up with some clever idea, and I did, mainly it being a screw that could be put through that. I still will go with that. I'm going to trial it on full-size struts with the hub, because the hub stays the same, which is kind of nice. But if I just hide some of these things just for clarity's sake, so we're left with a single strut, and I'll get rid of that. Sorry for the zoom, because there's nothing, it's not referencing anything, but what have I got here? I've got some erroneous lines here. I'll get rid of that. You can see how early in the design process or thought process it is. But anyway, we have the hub here. We have a plate that was originally designed to stop any chance of the high load possibility from splitting the timber at the end of the strut. so this plate would stop that from happening. But on the top bolt, top hole, we have a bolt. The gap here between the nut and the inner surface is for an interface item that will nest into the curve of the tube. But this is a straight piece of metal that would be sticking up in the air, or could be. And when the where are we? There we go. When the strut is inserted, bolted up, then that plate can be bent down tight onto the surface. In this case, I've shown a rebated surface, and it can be screwed down, so there can be no way for this to pull from the hub. After all, it's got the plate which is bolted to the hub. Now this can be done actually underneath as well. So if you wanted to forego this, which this makes it a very viable option, you could have a straight bracket bolted to the hub and then bent down, bent up, and then screw fixed. The reason I'm not going with that at this stage is the aesthetic side of it. I don't like the brackets. It just looks a little bit tinny and cheap for what I'm trying to achieve. Maybe. As I said, I still like this part of it, threaded rod into a dowel that will take high loads, and this top one takes a lesser but not non-existent load for wind uplift or some dislocation of this part of the joint. The smaller dimes actually only have brackets on the bottom, and that's because the bracket itself can resist the bending moments or the bending forces imposed upon it. But the bigger you go, the more necessity to have a double plate or fixing in the dome. Now, as I've said, this has always been in the back of my mind. I've always wanted the connectors to be easy to make and able to be used in a scaled up version. So if I took this, in fact I will show you my thinking. So this at the moment I believe is a 90mm, yes, 90mm timber, so it's not all that heavy. But if I came into here and I move this down, just say 50mm, this will make this a much heavier dome, bigger dome, or capable of being in a bigger dome. And all that needs to happen is the tube can be extended down, the fixings can be lowered to a lower position, or now that it is in this sort of orientation to the surface and the lower one, you could just have two of these being your sole fixing and get rid of this bracket, or lower it down and have the bracket there as well. So I think this simple approach is worthy of some consideration. I'm actually going to raise it to the top of my concentration when I'm making these things. And as I said right at the beginning, I'm doing this in SketchUp, and so I'm going through the theoretical idea of it, just the design on paper or screen type process. And as I said, there's lots of people that have used a bit of metal, they've bolted it together, screwed it all onto the strut, and they've got a dome. But my end goal had certain demands, and this seems at this stage to meet all of them. Screw down through the top, yes, still have that as a high priority or high preference, or this. I'm going to flop backwards and forwards between the two, screw into the end grain, yes, a proper a Spax or equivalent type of screw, 150, 200 millimeters long, something like that. They've got a very aggressive, well-designed thread, but this approach means I can put multiple fixings along here and it isn't going anywhere either. That's something that you can cut, or you can buy straps of these sorts of dimensions. This is about 35-40 mils wide. It would want to be maybe 1.6, 2 mils thick, 3 mils thick, you know, just whatever you're able to bend easily, and that ain't going anywhere. I reckon that's not a bad option. I will do some more drawing showing the different options like this with the heavier timbers, and I will come back to you in another video. So at this stage, only this or a variation of this will be what I'll be looking at in the immediate future. I can put, for the moment, aside the triangle type construction, one of which I still favour quite highly, but this has taken my concentration for the near term at least. Rightio, that was it. Very positive little camper I am, so I'll leave you alone and I will see you in the next video. Okay, bye now.